In 1903, a group of workers digging a drainage ditch in Somerset, England, struck bone. Not animal bone. Human bone. They had just uncovered a nearly complete 10,000-year-old skeleton. For over a century, this ancient skeleton known as Cheddar Man was celebrated as one of Britain's oldest known residents. But in 2018, scientists did something incredible. They sequenced his DNA. And the results absolutely shocked the world. Cheddar Man did not look like most modern Britons. The genetic data was clear. One of the earliest known people in Britain had blue eyes and dark brown to black skin. To us today, that combination feels highly unexpected. But it forces us to confront a much bigger question. How did human skin go from universally dark to the incredible range of colors we see across the globe today? The answer doesn't start with race. It doesn't even start with geography. It starts with a single molecule, melanin. Melanin is the pigment that gives your skin its color. The more melanin your body produces, the darker your skin becomes. But melanin isn't just cosmetic, it is a shield. Think of it as billions of microscopic umbrellas inside your skin, absorbing harmful ultraviolet radiation from the sun before it can damage your DNA. Most mammals use fur to block the sun, leaving the skin underneath relatively pale. But humans are strange mammals. Somewhere in our evolutionary past, we lost our fur, and that changed everything. Around 2 million years ago, early humans like Homo erectus began relying on endurance hunting. Instead of sprinting to catch prey, we followed it for hours under the brutal African sun. This gave us a massive advantage, but only if we could stay cool. Thick fur traps heat and blocks sweat, turning your own body into an oven. Over time, early humans with less body hair could sweat more efficiently, run longer, hunt better, and survive. But losing our fur created a deadly new problem. Now, bare skin was exposed directly to intense equatorial sunlight. To protect us, natural selection pushed hard in one direction: more melanin, darker skin. By the time modern Homo sapiens emerged in Africa around 300,000 years ago, dark skin was the default. It was the original human skin color, not for identity, but for survival. Yet, melanin comes with a major trade-off. While it blocks harmful UV radiation, your body actually needs a small amount of UV light to produce vitamin D, and vitamin D is non-negotiable. It helps your body absorb calcium, builds strong bones, boosts immunity, and influences reproductive health. In sunny Africa, this trade-off wasn't an issue. The sunlight was so intense that even dark, melanin-rich skin could synthesize plenty of vitamin D. But then we started moving. Around 60,000 years ago, some populations left Africa and migrated north, following animals, changing climates, and new opportunities. The farther north they went, the weaker the sunlight became. At high latitudes, the sun sits lower in the sky, its rays pass through more atmosphere and less UVB radiation. The exact light needed to make vitamin D reaches the ground. Suddenly, the dark skin that kept humans safe in Africa became a massive liability in northern environments. Because it blocked so much UV light, people couldn't produce enough vitamin D. Without it, bones grew weak, children developed rickets, pelvises formed incorrectly, and childbirth became incredibly dangerous for women. This became an evolutionary filter. Women with slightly lighter skin absorbed more UV light, produced more vitamin D, had healthier bones, and were far more likely to survive childbirth and pass on their genes. But this raises another mystery. If the pressure to lighten skin was so strong, why did Cheddar Man still have dark skin 10,000 years ago, after humans had lived in Europe for tens of thousands of years? The secret was their diet. These early Europeans were hunter-gatherers. They ate wild animals, liver, eggs, and fish. Coastal groups relied heavily on marine foods packed with vitamin D. This diet acted as a nutritional backup system. Even with dark skin, they got all the vitamin D they needed from their food, so the evolutionary pressure to lighten their skin remained weak. Then came the agricultural revolution, and everything changed. Around 10,000 years ago, farming spread into Europe from the Near East. People settled in villages, cleared fields, and shifted their diets drastically. Instead of a nutrient-rich hunter-gatherer diet, farming communities relied heavily on crops like wheat and barley. Grains can feed a massive population, but they contain almost no vitamin D. Suddenly, the dietary safety net was gone. In the weak sunlight of Northern Europe, humans had only one option left. They had to absorb more UV light through their skin. The evolutionary pressure skyrocketed. Those with lighter skin survived, while those with darker skin struggled. Then, a single genetic mutation accelerated the entire process. A tiny copying error occurred in a gene called SLC24A5, reducing melanin production by roughly 30 to 40%. Someone, somewhere in or near the Middle East or Southern Europe, was born noticeably lighter than those around them. In a low UV, farming-dominated world, this mutation was incredibly advantageous. It swept through European farming populations in just a few thousand years. But the story gets even more fascinating. That European mutation is almost entirely absent in East Asian populations. Yet many East Asian populations also developed lighter skin. How? They evolved it independently, using completely different genetic mutations. This is what scientists call convergent evolution, when different populations face the same environmental challenge and arrive at the same biological solution through different paths. It is the same reason dolphins and fish both have streamlined bodies, even though one is a mammal and the other is not. Light skin did not happen just once. It happened multiple times. Ultimately, human skin color is not a story of race. It is a story of sunlight, diet, migration, and survival. Dark skin protected our ancestors under the intense African sun. Light skin helped us survive in low UV northern environments after our diets changed. Neither is more advanced, and neither is more primitive. Each is a brilliant biological solution to a specific environmental puzzle. Cheddar Man reminds us that the ancient world did not look the way we often imagine. Skin colors are not permanent, ancient categories. They are highly dynamic, recent adaptations written onto our bodies by geography and survival. If you found this deep dive into our shared history fascinating, make sure to hit the like button, subscribe for more evolutionary stories, and let us know your thoughts in the comments below.